Hello, everyone. Today I'm going to be playing around with the GPT-oss model. I went to a meetup last week from Ollama that also had someone from OpenAI and VLM, and it was talking all about the GPT-oss models. And so now I am very intrigued by them and want to play around with them some more. So if you're new to the GPT-oss models, these are open weight models from OpenAI. We've been excitedly waiting for OpenAI to actually release some open weight models, and they did. So there's two sizes. There's the 20 billion parameter and the 120 billion parameter. The idea is that that these can actually be run on consumer hardware, depending on what your consumer hardware is. So when it did first come out, I used Ollama to pull the 20 billion model locally, and my local machine is a Mac M1 with 16 gigabytes RAM, and I was able to run it, but very, very slowly. I only got like 6 tokens per minute, which is very slow, and to the point where I was like, okay, this isn't reasonable. I don't think I can use this. So I did end up clearing it off my local system, but I've talked to lots of other people who have run the GPT-oss 20 billion parameter model locally. And so what it generally seems is that you need more than 16 gigs of RAM, especially on a Mac. So if you have like 32 gigs RAM, 64 or 128 gigs of RAM, if you have an amazingly tricked out Mac like that, then you should have no problem running it. The founder from Ollama that was demoing 20B, he had a 128 RAM Mac, and his local 20B ran so fast. It was amazing. Yeah, so you can try running it locally if you think you've got the hardware for it. But since I don't have the hardware for it, I've been experimenting with other places to run the OS model. So one place is on Azure Container Apps, which is basically deployed containers in the cloud. Let me paste this in the chat, right? So here's the Ollama page where you can learn about it. And yeah, so where I deployed it next was on Azure Container Apps. So basically a Docker file in the cloud using the Ollama Docker image here. And then once it started, I went to the console for the app, right? And here, if I type Ollama, it's got Ollama on it, right? Because we're using the Ollama Docker image. And then I already pulled the 120B model, so we can see that one. But let me go ahead and pull the smaller model too. So we just say, okay, let me do Ollama. Let me just reconnect here. Okay. So let me pull the smaller model, Ollama list. Okay, Ollama pool GPT-oss 20B. All right, so I'll pull this 20B model. Oh, we need another S in there. Ollama pool GPT-oss 20B. All right, so that's going to pull the 20B onto this machine so that we can run both the 120B and the 20B. So this is what it would look like if you were running this locally on your machine. If you had, a good enough machine, you would do an Ollama pool onto your machine and then run it there. But here I'm pulling onto the container app instead, since I just don't have the ability to run it locally. So it's almost pulled now. And then once it's pulled, then we can actually interact with it. Let me see. GPT-oss. All right. Okay. All right, so it's just, okay, so it's almost done downloading there. All right, and then Ollama list. Okay, so now we've got the 20B, we've got the 120B. And so now we can do Ollama run and say, all right, let me actually interact with this model and see how it works. Like, okay, we'll just say hi. Okay, and what you'll notice immediately is that this is a thinking model. So you can actually see the thinking. It says thinking, user says hi, done thinking, right? Be like, okay, well, you know, what is da-da-da plus da-da-da, do some math, okay? So then it does some thinking and it gives out the answer. So immediately we can see this is a reasoning model, and it's not just a reasoning model, it's a reasoning model that shows its thought process. And that's interesting because like DeepSeek was one of the maybe the first model that showed its reasoning process, and the OpenAI reasoning models have never shown their reasoning process in the API. They've always shown you how many tokens they used, but never the actual process. So this is, I think, the first reasoning models from OpenAI that do actually show their reasoning process. All right, so now, so this is working, and you know, now we can mess with those 20B and 120B. And what we can do is actually interact with this this Ollama endpoint via an API, right? So what I've got is I basically export my Ollama URL and I say, okay, this is where I'm running my Ollama server. It's on this container apps URL here. And then I can send a post to it. And this is going to the /API/generate, which is an Ollama endpoint. And, you know, it's got a prompt in there, right? So that's sending it to the 120B model and treating it like it's, you know, like an API, because it's exposing an API on the public port. And I actually did that earlier, so you can see what came back. There's a lot of what looks like token numbers that's in the context field. And then there's a long answer here, right? So here's the response. And there. So that's still running because that was kind of a large question for it. But since we can interact with it over an API, that means we can also interact it via the OpenAI Ollama endpoint, right? So Ollama has a compatibility layer for OpenAI. If we look at get the docs open for that. Here, go to docs and OpenAI. Okay. So this is their OpenAI compatibility layer. So the cool thing is that if you already have some code that works with the OpenAI SDK with the chat completions API, then you can point that at your Ollama endpoint and use it. So that's what we're going to do with this one. Oh, we can see it did finally respond with a long answer. I'm not sure what this context is because it looks like a bunch of tokens. And I don't remember context. Oh, but context, yeah, maybe it is a bunch of tokens. That's because that's the API, the generation API endpoint. Okay. All right. So now let's try it out from the OpenAI SDK. Okay. So here I've got some code. So here my code can connect to Azure, Ollama, GitHub, or OpenAI. So I'm going to have it connect to Ollama. And I have the Ollama endpoint here, right? So that is the container app URL /v1. So whenever you're running an Ollama server, it exposes an OpenAI compatible endpoint at /v1, right? So we're saying, okay, that's our OpenAI endpoint. And this is the model we're going to use. So I configure the OpenAI constructor to point at that endpoint. It doesn't need a key. There's no key for this. And then we grab the model name. And now I'm using the chat completions function here. And here I've got some sort of, you know, somewhat difficult question about weighing coins to figure out which one is counterfeit. and I can pass in a reasoning effort. I don't know. We should check to see if that makes a difference. But it does let me pass one in. All right, so let's just run this and see what happens. Okay. So we should probably start with an easier question, but it's doing its thinking now. We could also, of course, point at an easier the lower parameter model, though that could take more time. All right, so here's the response. So we got back the response, and yeah, it took a while because it was actually a fairly long response. So it says how to do this coin weighing thing, and we can see how many tokens it took in the token usage. Doesn't total tokens, prompt tokens, completion tokens. I don't see reasoning tokens there, so I feel like maybe the token. I don't know if the token report is correct. Let me try. Let's just do an easier thing. So okay, just add how many. Oh, let's do this. How many R's are okay? Well, we have to do lowercase R's are in strawberry. All right, let's try this. It's the classic. So this should get a faster response. Okay, it says the word strawberry contains 3 letters R. That's correct, right? 1, 2, 3. Yep. Now the question is, what reasoning did it do? Because right now we're not seeing the reasoning, but let's see if we can see it. Hello, Carlos. All right, so where is the reasoning? So what I'm going to do is print out the entire response so that we can see everything that it's sending back. So we can see where is the reasoning, okay? So what we can see is that this is the full response, right? And it has choices, and you only see one choice because the default is n equals 1. I think everybody does n equals 1 these days. In theory, you can say like n equals 2, 3, and basically get the LLM to answer your same question multiple times, and then you could decide which one you want the most. But I've never seen anybody actually use an n greater than 1. Hello, Robinson. All right. So yeah, so we've got n equals 1, which means we get one choice back. And then it has a message. The message has the content, which is the answer I showed, but also notice the message has reasoning. So the reasoning came along with the message. Now, this is interesting because other APIs that I've used in the there'll be a separate, they'll separate it somehow. But this one has both content and reasoning in the same. So what we could do is say we'd be like thinking, right? And then we'll say print response dot choices 0 dot reasoning, good, and done thinking, and then we'll print the actual content. And then I just don't know if the usage is correct because it says completion tokens 50. The question is this actually 50 tokens? Let's go to the OpenAI tokenizer and see the tokenizer uses them. The question is that tokenizer correct? But this is 24. Okay, that's 24 tokens. And then if we add in this one, then we get to 40 tokens. Okay, so maybe that is correct. Maybe it is using 50 tokens overall for the full response, combining both the content and the reasoning. Okay. We got more questions. How many blues are in blueberry? How many R's? How many blues are in blueberry? So blue. How many R's? And then is it using a Python string.count function? No, it isn't. It's not using any functions. The next thing I do want to try is function calling, however. Okay, so we'll show everything here. Usage. Okay, so let's run that again. We can and I did it wrong. So it's not choices 0 dot reasoning, it's choices 0 dot message dot reasoning. Okay, that should be correct. Let's try that out. Message 0 dot reasoning. Yeah, and the OpenAI SDK. Maybe I have an older version of the SDK because it doesn't even know what that is. But there we go. It worked. Let's see. Thinking. There's the thinking and then done thinking. Let me get rid of the full response here so it's prettier. All right, and let's try the blueberry one as well. And try this out here. Okay, so thinking, the thinking. Okay, so that was reasoning effort low. So let's see, does this reasoning effort have any actual difference? So I'm going to try sending us changing reasoning effort to medium, and it is taking longer. Okay, that's good. What if we do high? Is it going to think a lot? They did say in the gpt-oss meetup that there was a big difference between low and high and that you should be like careful. Oh, it definitely is different. Okay. So we see a huge difference when we go from low to high, right? Very simple. The word blueberry contains the letter R. How many times? Let's count. Da, 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 blueberry, blah, blah. Ensure we confirm. Is this a trick question? It checks the casing. That's good. Given that it's simply potential. Okay. Yeah, so it actually does do a whole lot more thinking when we change the reasoning effort to high. So definitely keep that in mind if you're using this model, is that there's a big difference between low and high. They were in the meetup that I went to with gpt-oss. They were showing examples of the answering like law, exam questions that were quite difficult. And there the reasoning was like pages and pages long, like really, really a lot of reasoning. All right, and we can see this took up more tokens because of the reasoning. So completion tokens is including the reasoning. Sometimes you get token details separate. Let me remember how to can I get the token details separate? I don't know if they've implemented that. Okay. All right. So okay, good. So it's reasoning. So we've definitely seen this as a reasoning model. We can see it's reasoning. That's good. The next step is function calling, because that's the other big thing that they emphasize with this model, is that it should be able to do function calling. And so this is really interesting to me because I have not been able to get any of these small language models to really work with function calling, and especially when you want to use it with fancier things. So let's try that out next. So here I've got a basic function calling. This is my most basic function calling example. So what this has here, it's got the function described with JSON schema. This is the lookup weather function, where the lookup weather function takes a city name and a zip code, or a zip code, either one. And then I say, okay, what's the weather like in Berkeley? And let's try this out, right? And see if it can call that function. Now it's not going to really, like, the way function calling works is that it's not actually going to call the function. It's just going to tell us what it thinks, how it thinks we should call a function, like what arguments we should send into it, right? So the goal of function calling is for the LM to say, oh, I see you have this function lookup weather. I think you should call that with these arguments. So here we got the response: lookup weather, city name, Berkeley, zip code, empty. Oh yeah, the question is, am I using 20B or 120B? I am using, that's a good question. Right now I'm using 120B. We could actually change to 20B. I guess let's just go ahead and try this first one with 20B just to see if we see a big difference. I do have both of them running on this container in the cloud. So, okay, so here we go. So it was a little less completion tokens, like 184. To get that answer. So, but we can, yeah, so we see like the 20B, the 120B, maybe a little less reasoning, but we got similar answers. For the function calling, I'm going to go back to 120B just to give it the best shot of doing a good job. But it's always good to look at both of them so we can go back and forth. Okay, so let's see. Okay, so for the function calling, it did recommend, how to call that function. So it's good. It does seem to be implementing function calling. Now, the question is, where is the reasoning? Because this is a model that, in theory, is doing both reasoning and is doing tool calling, and actually reasoning about the tool calls. So let's just take our code from before, thinking. and put it in here. Put a little like, I don't know. I want to like a little emoji here, like thinking. We should do like the little this one. And then done thinking. Stop. Stop. Okay. All right. Let's try this out and see what the thought process looks like when doing tool calling. The question is 20B also reasoning? Yes, they're both doing reasoning. It seemed like there was slightly less reasoning for 20B, like 20 tokens less than the other one, but that was just for one example. So we'd have to see, but they are both still reasoning. Okay, so now we can see the thinking that it does. So it says the user asked whether in Berkeley, need to get whether via function, need city name Berkeley, let's call function, right? So that is what the thinking looks like. Right now we're on reasoning effort medium, which is probably a good level to stay at. So this is working with a single tool call, but now I want to get fancier, right? So let's go to this one, function calling extended. So this one has the lookup weather function, and this time I've got it defined here so I can actually call it as well. Okay, so this one, are we giving it a single tool? Okay, so this one is interesting because we both have the function defined. We have it like defined in JSON schema. That's what we're going to send to the LLM. We also have it defined locally, and it's going to just basically return back some fake data. So what we're doing here is we're going to get back the response. Then we're actually going to call that function. Then we're going to append the response from that function to the conversation, right? So the user asked the question, the LLM said, okay, call this tool. We say, okay, here's the response from the tool. And then we're going to send that full set of messages to the LLM again and see how it responds. Now, this is significant because this is the point where I've seen small local models fall over, is that once a conversation starts to have actually tool call responses, then we get worse results. So let me see. And I also want to just put in, so every time we do a call to one of these models, I want to show the thinking. So I'm just going to do that. Just put this on top of both of these. Okay. And then let's do reasoning effort equals medium. Okay. All right. All right. So let's try this one out. All right. Okay. Let's see. What is it? Chat completion message has no attribute reasoning. Where did it? Okay. So it died on the second one. It actually worked on the first one. Let's see. Okay. All right. We had an error here. I'm just going to get rid of the reasoning here. So what we see is that for the first one, that's similar to before. And then let's see if we can get through the second call. Okay. Okay. Interesting. All right. So what happened here is that let me share the full messages to really explain what it's doing. Let me bring in rich print because it's a little nicer. And then I'm going to say print messages to show you what it's responding to. And run this again here. Okay. So, there's the system message, you're a weather chatbot. This is the user message. Is it sunny? And then the next message was was from the model itself, which was a tool call message that says, hey, we need to call this tool call. And then the message after that was a response from the tool call where it says, okay, this was the tool call. Here's the response. So all of that gets sent to the LM. And the LLM says, oh, okay, let me answer the question. And so it says, yes, right now it's sunny in Berkeley, CA with a temperature around 75 F. So that worked, which is good because that is the basis for agents, right? The reason this matters is that if that worked, there is a chance that we can use this model with agent frameworks. A chance, like still other things can go wrong. But the interesting thing is that we got that error when I tried to print out the reasoning. So I want to see what happened. Let me just look at the full response there. and see why did we lose the reasoning in the last call, because that might be a bug. Oh, you're seeing the reasoning effort. Okay, we could try. So reasoning effort should be a default of medium. But yeah, it's true. We can add reasoning effort equals medium here. Maybe that would help. So if we look at this actual message, we see the choice, and it does not, and the message does not have a reasoning parameter on it. So let's try what happens. That was a good call. So Irfan suggested reasoning effort. So as I understand it, it's supposed to be medium, but of course we're going via Ollama. So, things could be different. Maybe it doesn't have a good default. It should be reasoning regardless because it's a reasoning model. So let's see. This time, yeah, we didn't get reasoning this time either. So this seems to be, maybe it's a bug where it's not giving us the reasoning when it's later in the thing. So let me just note this as potential bug, because when I was chatting with the Ollama folks at the meetup, and I was like, oh, is it going to handle this scenario here? And they're like, we think so, but you should test it and see. I'll say the follow-up message has a no reasoning field. So I'll post that in the Ollama issue tracker afterwards. But the good thing is, even if it doesn't have the reasoning field, that's okay, because it is actually working. So that one worked. Now let's try with multiple functions. Okay, so this time we have lookup weather, we have lookup movies. We're going to give it multiple tools it could call from, and see, can it do what's called, we call this parallel tool calling, the ability to say that multiple tools should be called. So let's try that out, and we'll bring in our thinking here, and we can say reasoning effort equals medium. Okay, and let's try this one out, multiple. Okay. All right, so is it you need to check weather, then get movies, also need movies, use it, let's call both. Okay, so this is interesting. It says let's call both, and then it only shows me look up weather. So I think that it does not understand. I don't think it can do what we call parallel tool calling. Let me find a reference for parallel tool calling, and maybe it's even in their docs that they don't do parallel. Let me see. Parallel. Okay, they don't talk about it here. Function calling, parallel function calling. So it can, in theory, the OpenAI models can choose to call multiple functions in a single turn. But in this case, it doesn't seem to be doing. So I'll just say potential bug. It did not output 2 tool calls. No support for parallel tool calling. I don't know if this is a bug or feature. It might be just something that it's not in the thing, but it did say, let's call both, right? And then it did not call both. Maybe it would call both in a subsequent turn if we did this with over multiple turns. Did I have doc strings for multiple functions? So the doc strings are here, right? So in this case, I'm just defining them, defining the schema inline. Right, so this is the equivalent of the doc string. If I was defining it with a Python function and using like a tool decorator or something, it would pull the doc string from the pull the description from the doc string. But this is the equivalent of the doc string. And this code does work with OpenAI models, right? Do I have one? Let me see if I can. Do I have one of these running right now? Let me see if I have a GPT-5 running where I can show you what this would look like with a GPT-5 model. Let me try this out. I don't remember if this is a deployment that I have open up right now. This one, but well, we'll find out soon. Okay, let me get rid of the reasoning because we don't have that parameter on that model. And let's see. So this is with, there we go. So this is what it looks like with GPT-5. What are we running? Yeah, GPT-5 full. So GPT-5 full will actually suggest multiple tool calls within the same message, right? So that's what we mean by parallel tool calling. And that's what didn't work with the GPT-oss model, right? And so that might just be a known limitation, or it could be a bug on the Ollama side, right? I don't know. So I'll put another issue in the Ollama forum. I'll just put some reminders here about that and see if that's intentional. Okay, so that's function calling. But the fact that we got this far means we might be able to get this working with an agents framework. So let's try an agents framework next and see if we can actually get this model working with an agents framework. Because if we can, then that's really, really cool. Because I've had such a hard time using SLMs for agent frameworks. We should also try to make sure the 20B also works, because for most people, it's the 20B they're going to be using locally. So I just have to find I have too many repos. Here we go. Here's some agents demos. Okay. So let me go ahead and, all right. So first, let's make sure, let's just check with the 20B, because we want to know, is this working with a 20B too? So we'll try this one. Okay, so this is the one that does the tool call and then gets the tool call response. Okay, and yeah, but the 20B also working. Okay, great. So now I'm going to take my environment and bring it over there. Ignore that. That's a dead token. Okay, Ollama endpoint, API host Ollama. Let's see if I even have, do I even have Ollama support for these? We'll find out soon. All right, let's try OpenAI basic. Okay, so there we go. So base URL, let me get that. Bring this in here. OS get env. All right, I'll do OS environment. All right. And then the model name is going to be this one. Ollama model. All right. Okay. So here we are trying, so we've got Ollama endpoint, Ollama model. Okay. So this is using the OpenAI agents package. And this one's super basic, doesn't even have tools. We're just making sure that the package, that it works. So let's try this one, API agents. Okay, examples. OpenAI agents, basic. Because the first test, so as soon as we use like an agents framework, that's a level of abstraction, right? Okay, good. So that worked. So here it just, there was no tools. It just said, oh, you're a Spanish tutor, respond in Spanish. And that worked. It responded in Spanish. All right. So now let's actually get some tools happening in here. So let me take this configuration here, put it in here. All right, so here we've got a tool defined similar to the other one, but this time we're using nice decorators because we can do that with this SDK. This is a decorator that comes from the OpenAI Agents SDK, right? So we imported it. So we have a decorator for function tool. And then, so it just randomly says sunny or rainy. We have another decorator for activities and another decorator for get the current date. And this is a weekend planner tool. And we give it the list of these 3 different tools. And then I ask, oh, what can I do this weekend in Seattle? So the idea here is with this SDK, it should just iterate and keep calling tools until it finally gets a response that is not a tool call. So let's see if it works. This is the kind of thing, multiple tool calls, the conversation tool calls, that usually doesn't work. Okay, let's see. It says the API key option must be set and let's make sure we're doing API host Ollama. Why would it suddenly have? Okay, let's see. OpenAI provider. Okay, it says it doesn't like our API key, but API key should not matter, and it didn't matter for the other one. Let's just delete all this code. Make sure that we're using this code. The API key, why? Okay. Maybe we didn't pass in our model correctly. Let's see. So this one, we do model equals this. All right, so agent name. Oh, we did not. Oh, this is a issue in my code here. Okay, so that's fine. So let me go ahead and clean this up a bit. All right, so the agent needs to take in this model parameter. Let me go and add this to the imports. Okay. All right, so now the agent should take in the model parameter. All right, there we go. So it just wasn't configured correctly there. All right, so now the agent should be pointing at our Ollama client. Okay, so we can see I put prints or logs in each of the functions so we can see when they're called. So it's, oh my gosh, it worked. Did that really work? Oh, wow. I'm impressed. These things usually don't work. Let me show you with like a local one. Let's test it with a local one, right? I've got Llama 3.1 latest in here. And let me just change this to the local endpoint, Llama endpoint local. Thank you. It's great. Ollama endpoint, and then Ollama model equals that one. Yeah. Okay. So this one worked, right? It didn't do parallel tool calling, which is fine. What it did was it just kept on like it would like make a tool call, get back a response, make another tool call, get back a response, make another tool call, make a response. So that's fine. Many of the agent frameworks don't necessarily expect parallel tool calling support. So it basically did like linear tool calling, right? And did it in a sequence. So it figured everything out. It got the activities for the right day, and then came up with the response. So let's try that with another small model, the Llama 3.1, which technically supports tool calling, but practically I've had issues trying to use it. So let's see how they compare. So the question was, you thought chat and completion were two different types of models. Here, using chat completion combined. I'm using chat completion. The other kind of model is like called completion, which is not where you're just doing like a prompt, like a text completion, but generally, I don't think most people are using that anymore. So I'm always using chat completions. Now, there's a good point though, is that there's another kind of API called the responses API, and this model is supposed to work really well with the responses API, but Ollama doesn't yet have support for the responses API. So that's like a big open issue on the Ollama repo. So do star that issue. I think I filed the issue, and I asked them about it when I was chatting with them last week, right? So responses API. There we go. Okay. So this is a very popular issue. So the responses API is an like a newer kind of API from OpenAI that is, optimized for OpenAI models in particular, and which is supposed to be work better with GPT-5, but also with the GPT-oss ones. But we can't use it via Ollama yet, so I'm using the chat completions API. And then, how does it know to do tool calling in sequence? Is it the system instruction? Oh yeah, it's a good question. Yeah, we should look at the system prompt if we can. I think I can show you that. So here, remember that we were testing with Llama 3.1, and as you can see, it only managed to call a single tool, and then it just kind of gave up. It did actually answer the question based off the single tool, but you can immediately see there's a difference there. I see Tushar says that Gemma 3 also supports function calling. I have heard good things about Gemma 3. So that would be a good one to try too. So maybe that would have better success. I don't really have enough space on my machine to download many more models. Let me see how big Gemma 3 is. Gemma 3. There is a 4B. I probably could fit a 4B. Let me just check how much storage space I have left because I'm always like too low on storage space. But let's see, storage. I know I need, okay. I only have 10 gigs left on my entire machine, so I probably shouldn't download a new model today. I need to do some clearing out. But that would be a good test, is to try out the Gemma 3 as well and see how that compares. And we should also try, so right now we're on the, we are on the 20B model, so that's good. I wasn't even doing the 120B, so we're doing the 20B model, and it did quite well. So yeah, so it's definitely better than Llama 3.1, which is the one I was using most recently for tool calling. Okay, so the question was, how is it via system instruction? So when I want to use look at the system construction, what I typically do is I change the logging level to debug, because then we usually will see the full requests that go out over the wire. So let's see if we change it to debug, if we can see, because when, once again, when we use an agents framework, usually it's doing some sort of prompting behind the scenes, right? Okay, so here we can actually see what gets out, and I don't think it actually added anything to our. Looks like it didn't add any additional prompts, so it just it just sent the system prompt that I had and all the tool calls. So in this case, it knows that oh, look, and we can see reasoning. Okay, so here's the response. All right, so let's just see what reasoning it decided to use, right? So it said, okay, first, we need day of week, use today date. We don't have system date, use get weather. Okay, so then it got back. So the first thing it called was get current date. It got back the response from that, which was the current date. And then it could see what tools it could call. And let's see, where's the reasoning? Reasoning. Okay. Let's see, instructions, help plan. It says we already have current date. So it's not, yeah. So it's just that it sees what information it already has and then decides what it's going to call next, right? So it says we need to ask for date, but we already have the current date. And then it calculates the weather. Should we use get weather, good activities? So then it ends up the next one, then it calls the next one and gets back the response. And then if we look at the response for that one, it says, okay, we have the current date. We need to give suggestions. We also need weathers. There's a get weather function. So it's just deciding as it goes along based off of what it has so far and what information it still needs. And then we get back the response. Okay, so that works. So this is like the most basic kind of multi-tool agent, right? We gave it a list of tools. It just kept iterating on. This is very similar to the lane graph reactive agent. Let me see if I have a React agent in here. That's a graph one. What about this one, the GitHub one? That's with the GitHub create React agent. Oh, then that one requires the GitHub MCP server. Let's see. Oh, that one's a local one. I would think that the React agent would be similar to this one. Given that it's working with that. So the question was, how come the last model tried parallel calling? So this one, we haven't seen, the GPT-oss model has not done parallel calling, right? It's only ever called one at a time. And I don't think I've seen any of the local Ollama models do parallel tool calling, so I think it's just not supported. The only time we saw parallel tool calling is when I used the GPT-5 with this example here, where I passed it, multiple tools, and it was able to call both at once. But I think a lot of these agent frameworks don't expect that the models are calling multiple tools, so they might be able to handle if the model does call multiple tools, but they don't rely on that happening, right? Okay, so what do we want to see next week? I could try getting a lane graph one working if we want to try and get a lane graph one working. Let me see. Okay, so we need to let's get that one requires my token. Lane graph agent. Okay, let's just try this lane graph agent. All right, so which one? So right now we're using Ollama. Okay, so we have a lane graph agent, and let's add Ollama support to it. Okay, so we'll just do okay, this is API host equals GitHub. Yeah, here we go. Okay. Oh, there we go. All right. Let's see if this will work with lane graph. Okay. Okay. It worked. But let's see, what did it actually do? So this was using lane graph, like the graph API, and then the tools were these tools here. So yeah, very similar, right? So we bound some tools, and this ones were like, playing songs on, some pretend devices I have, right? So we bound the model to the tools. We explicitly said the parallel tool calls false. So that's interesting. So in lane graph, when you bind tools to a model, it defaults to allowing parallel tool calls to happen, but you can explicitly turn it off. If I did it true, I would assume it still wouldn't force tool, like I would assume it's still going to work. Let's just see. Because I think that just means whether it'll whether it allows it, right? So it's probably just going to pass this parameter on to the OpenAI SDK when it makes the call. And I think this is still going to work because it's not going to make tool calls. So what we can see here is that lane graph, if the API does do parallel tool calls, then presumably it's going to support it, and it's going to parse out the parallel tool calls, right? But if it doesn't, then it'll work. So we might as well set that to false since we're not using it anyway. Okay, so lane graph worked with the model bind tools, so that's good. Let's try Pydantic as well. Let's see, do we have support for it now that it works with Ollama? I can add back Ollama support to all of these. Okay, Ollama endpoint, Ollama model. Okay, and let's try this one out. Tools.py. Okay. So we got the weather, we got the current date. Interesting that it got the weather before they got the current date. Getting activities. How did it manage to get the weather without knowing the current date? Oh, because it didn't take in a date. We should make the date, right? Make it think that it needs to know the date first, right? So we don't have to tell it the order of tools to call, but we need to give it the intuition that, oh, well, date is important for get weather. So, so we'll just say date. We'll just pretend our awesome weather API. Okay. So now we do it. It should call get current date first, just because it should see. There we go. So this time it called get current date. Then it got the weather, and then it's getting the activities. Okay, cool. So what we're seeing is that, in fact, even with a 20 billion parameter model, we are able to practically use it with agent SDKs, and that's very exciting. There's some question as to whether we can practically use the reasoning, like actually display the reasoning alongside those SDKs, because most of these SDKs like don't necessarily surface the reasoning or know that there's going to be reasoning. But we can, at least if we already have code that's using these agent SDKs, we should be able to point them at the GPT-oss models and have it use it. So we only have a few minutes left. The only other stuff notable about GPT-oss is that it was specifically trained with support for two specific tools, which is the browser tool and the Python tool. Let me see this one. Okay. Output type web search call. So it was trained specifically for web search call and code interpreter call. So if we made a tool, how do we define a tool? Well, what arguments does it take? So when they trained this model, they gave the model access to these two tools, and so it's like particularly good at calling it. Okay, let me see. Maybe this status input. Is that what it would look like? So we've got web search. Yeah, so there's all these web search. So they trained it generally for function calls, but they also trained it specifically for web search, where you can search, you can open a page, and you can find. And then they've got like sample implementations you could use for these. So code interpreter call. So like presumably what I would do is make a function called function tool def, maybe this code interpreter call. I don't know exactly if that's what the function name should be. ID string status input. Well, the input seems good. Well, what does the function call look like here? Arguments. Just arguments. Okay, I'm thinking it takes in input. We got to figure out what it was trained on. Let's see. Code interpreter call. Output.append. Entry recipient Python. What does this look like in the OpenAI version of the SDK is my question. Default function properties. Let's see if they have some docs here. Code and interpreter. Okay, Python code execution. Defines its old tool description to override the definition. Okay, to enable the Python tool. Thing is that none of this is use Python tool with tools, tool config, Python tool config. Okay. GPT-oss tools, Python Docker tool. All right, let's see. GPT-oss tools. Here we go. Tools, Python Docker tool. Okay. And then Python tool, get tool name Python. Okay, so that's the name of it. And so maybe we would call it Python. And does it have a description? Instructions, use this tool. Okay. So that'll be our doc string. And what about a description of it? Tool name, description. That is description. Okay, but what argument does it take? It doesn't take an argument. It must take an argument. Make response. Or maybe it doesn't take an argument, actually. Wait. No, it should take an argument. Okay. All right. I'm just getting confused here. So where is the argument? Name string. Tool, get tool name. Okay. All right. Well, I'm going to go with input. And then, okay. We're just going to print out executing Python code. All right. Great. Good. Okay. And then you help users do data science. Okay. And then we say Python is the tool. Here we go. And then I make me a bar chart with 3 bars of 60, 50, 40. Okay. Let's just see how it does with that. OpenAI agents tools.py. Okay. All right, let's see. Oh, and I still have the debug mode on. Let's see. Okay. All right, and then it gives back a response, but it doesn't really look like it thinks it's going to execute it, right? Because the response should be like exactly just Python code, because we would need to run it. So I don't think I've quite done this right. So let me put it to do here. Figure out what exactly the tool description should look like. Because what I'm trying to trigger is what it was trained for. It was trained for a specific code interpreter tool. And I think if we give it exactly the right function description, then it should be able to call on its training and give out just Python output, right? This doesn't look correct because it also has instructions. So I need to figure out what that should look like so that we can use it from there. Okay, I see there's, question, a presentation on RAG tomorrow, using RAG slides, content for MCP. Let's see. Yeah, just message me on LinkedIn. I know we have people who have slides about MCP. I haven't made slides about MCP yet myself, but I do have repos. So just ping me on LinkedIn today. All right. Okay, cool. Thank you everyone for joining. I thought it was really cool to see the GPT-oss models, see what they're capable of. So remember, you can try them out locally if your machine is good enough using Ollama. You can try them out on Azure Container Apps, following this tutorial. That's what I did. You can also try them on Azure AI Foundry. So you can, not the 20B, but the 120B. So you can deploy that on Azure AI Foundry, and I've done that as well. And there's other ways you can do it too, because this is an open weight model. So whatever your favorite is of doing open weights. And that means I have to go now. So thank you all for joining. Super fun to try everything. Bye.